6th grade, Module 5, Lesson 2, Classwork, the area of right triangles. Classwork, Exploratory Challenge. A. Use the shapes labeled with an X to predict the formula needed to calculate the area of a right triangle. Explain your prediction. Okay, so I had to search a little to find these shapes that were labeled with an X, but I found them here on their website. So we have these shapes labeled with an X and this. So it looks like it's just a rectangle. So we have a rectangle, but we want to find the area of the right triangle. So it looks like if you take the rectangle and then split it in half, so it's split in half diagonally, then we would just be able to find the area of a rectangle and take half of it, and that would give us the area of a right triangle. So, for example, I couldn't write on that, but I can draw on here. So maybe this will make more sense. So we had it gave us a rectangle, and it's split in half. It's not a very straight line, but that's okay. So here we have a right triangle. What makes it a right triangle is it has a right angle. So we can find the area of that right angle by finding the area of the entire rectangle, which would just be length times width, or base times height, whichever you want to do. I'll say base times height finds us the area of the whole rectangle, but then we want to cut that in half. So you could either do divided by 2 or multiply it by 1/2. So you can kind of write an explanation for that. So formula for the area of triangles would be area is equal to 1/2 times the base times the height. Or you could also write it as area is equal to base times height divided by 2. Either way, same thing. So the area of the given triangle here, if I go back to this, it looks like it is, the base is 3, it's 3 across, and the height is 2. So 3 by 2 would be the area of the rectangle, but then we need to find half of that. So area of the given triangle would be 1/2 times the base was 3, the height was 2, would be, let's do 3 times 2 is 6, and half of that would be 3. So they would be 3, and maybe that's inches, or something. I'm going to say 3 units squared would be the area of that right triangle. Okay, B, use the shapes labeled with a Y to determine if the formula discovered in part A is correct. Does your formula for triangle Y match the formula you got for triangle X? So let's go back here and look at triangle Y. So here we have Y. This time it's a square. So to find the area of a square, we would also do base times height, but is the area of this triangle half of the base times height? So I'm just going to go back to here and draw a square. Okay, so let's say that's a square. We cut it in half. So we could find the area of the square, which would be base times height. Base, that's not the base. The base times the height. And then take half of it to find the area of that triangle. So I would say yes, that works. Yes, the area would be half the area of the square. I'm going to make this more specific, the area of the triangle. Okay, if so, do you believe that you have the correct formula needed to calculate the area of the right triangle? So yes, because 1/2 base times height is equal to area. So yes, because the right triangle area, right triangle's area will be half of the square's area. If not, which formula do you think is correct? So I'm just gonna ignore that because we do think it's correct. So area of the given triangle. So let's go back and look at the dimensions here. So we have the base is 3 units and the height is 3 units. So we would have 1/2 of 3 times 3. So 3 times 3 is 9. And then half of that would be, half of 9 is 4.5. So 4.5 units squared would be the area of that triangle. All right, exercises. Calculate the area of each triangle below. Each figure is not drawn to scale. So remember, you can either do this formula, 1/2 base times height, or you can do base times height divided by 2. You'll get the same thing. Those are the same formula, just written differently. So I'll try base times height divided by 2. So here we have a base of 15 times a height of 8, and we're going to divide that by 2. So the 17 here is, we don't need to use that. We don't need to know what that is, or we don't need to do anything with it. So 15 times 8 would be, 8 times 5 is 40, carry the 4, 8 times 1 is 8, plus 4 is 12. So we get 120 divided by 2, and 120 divided by 2 would be 60. So we get 60 feet squared as the area here. Number 2. We have 17 and 7/10 centimeters. So let's do base times height. So the base would be 11 and 4/10 times the height is 17 and 7/10. And then we'll divide that by 2. So let's do 11 and 4/10 times 17 and 7/10. So 7 times 4 is 28. Carry the 2. 7 times 1 is 7, plus 2 is 9. 7 times 1 is 7. So done with the 2. I'll put my 0 down. 7 times 7 is 28. Carry the 2. 7 times 1 is 7, plus 2 is 9, and 7 times 1 is 7. Again, get rid of the 2, and now I'll put down 2 zeros, and we just have the 1. 1 times 4 is 4. 1 times 1 is 1, and 1 times 1 is 1. So let's add those all together. 8. 9 plus 8 is 17. Carry the 1. 1 plus 7 plus 9 is 17. Plus 4 would be 21. 2 plus 7 is 9. Plus 1 is 10. Carry the 1. And then we have a 2. So then in the problem, we had 2 digits behind a decimal point. So there's a decimal point. There were 2 digits. So I'm going to move the decimal point over 2 places. We get 201 and 78 hundredths. But we need to now divide that by 2. So now it's time to divide it by 2. So 2, I'm just going to go ahead and bring up my decimal point. Now I don't have to worry about it anymore. 2 goes into 2 one time. 2 goes into 0, 0 times. So I'm going to bring down another 0. 2 goes into, or bring down the 1. Sorry. 2 goes into 1, 0 times. So I'm going to put another 0 there. We'll bring down the 7. 2 goes into 17, 8 times. 2 times 8 is 16. So we have 1, bring down the 8, and 2 goes into 18, 9 times. So we have nothing to bring down, no remainder. So our answer is going to be 189 hundredths, and our label is centimeters squared. Number 3. Okay, so they kind of slanted this to trick us a little bit. But if you turn it, we see that we have a right angle there. So that's going to make this the base and this the height. So the area is going to be equal to 8 times the height is 6 divided by 2. So 8 times 6 is 48 divided by 2. 48 divided by 2 is 24. So we have 24. Our label is inches squared. Number 4. Fractions, yay. So the area would be base times height. So the base is 8 2/3 times the height is 5 3/5, and then we're going to divide that by 2. So I'm going to bring it back to the box method. That's what I like to use with these fractions. I think it just makes it more simple. So 8 2/3 times 5 3/5. Or if you want to make them improper fractions and multiply that way, you can do that too. 2 different ways to do it. So here I'm going to get 40. 5 times 2/3 would give me 10/3, which would be equal to, let's see, 3 goes into 10, 3 times 3 1/3. 8 times 3/5, that would be 24/5. Or 5 goes into 24 4 times with 4/5 left over. And then 2/3 times 3/5 is 6/15. So now I have to add those all together. Find a common denominator. So our common denominator is going to be 15. So 40 plus 3, and remember how we do this? 1/3 is equal to how many 15ths? 3 times 5 is 15, so 1 times 5, that would be 3 5/15. Plus 4 4/5 would be equal to how many 15ths? This times 3 would be 12/15. Plus 6/15. Okay, now we all have the common denominator, so now we can add them. So I'm going to add the whole numbers. 40 plus 3 plus 4, here's the whole numbers. 40 plus 3 plus 4 would be 47. And then 5/15 plus 12/15 would be 17/15. Plus 6/15 would be 23/15. But if I make that into 23/15 into a mixed number would be 1, and let's see, 23 minus 15 would be 8/15, plus the 47 would give us 48 8/15. Okay, so we're still not done because we need to either divide that by 2 or multiply it by 1/2. I think fractions are easier to multiply than divide, so I'm going to do 48 8/15 times 1/2. So I'm going to do another model here. So we have 48 8/15 times 1/2. So 48 times 1/2, or half of 48, is 24. 8/15 times 1/2 would be 8/30, and then I just have to add those together. So we get 24 and 8/30. Or we can reduce that, and that would be 24. I can divide both 8 and 30 by 4, which would give me 2/15, which cannot be reduced, and our label would be, we were on meters, so meters squared. All right, number 5. Oh good, no fractions. Okay, so the area will be equal to the base, 21 4/10, by the height, 32 7/10, and then we'll divide that by 2, or we can multiply it by 1/2 if we choose to do that. So 21 4/10 times 32 7/10. 4 times 7 is 28. 7 times 1 is 7, plus 2 is 9. And 7 times 2 is 14. Get rid of the 2. Put my 0 down. 2 times 4 is 8. 2 times 1 is 2. 2 times 2 is 4. Done with the 2. Now I need 2 zeros. 3 times 4 is 12. Carry the 1. 3 times 1 is 3, plus 1 is 4. And 3 times 2 is 6. Add it all together. 9 plus 8 is 17. 1 plus 4 is 5, plus 2 is 7, plus 2 is 9. 1 plus 4 would be 9 and 6. And then we had 2 digits behind a decimal point, so I'm going to move it over 2 places. And we have 699 and 78 hundredths, but I need to divide that by 2. Or you can multiply it by half. Either way. Okay. Bring my decimal point up. 2 goes into 6 3 times. Bring down the 9. 2 goes into 9 4 times. That's 8. So we have 1 left over. Bring down the 9. 2 goes into 19 9 times. Bring down the 7. 2 goes into 17. Let's see, 8 times. Minus 16. We have 1. And 2 goes into 18 9 times. So there's no remainder, nothing to bring down. We get 349 and 89 hundredths. 349 and 89 hundredths kilometers squared. Okay, Mr. Jones told his students they each need half a piece of paper. Calvin cut his piece of paper horizontally, so like this, horizontally, and Matthew cut his piece of paper diagonally. So Matthew did diagonal. Which student has the larger area of his half of piece of paper? Okay, so just because they cut it differently doesn't mean that the area changes. So if it's the same size paper and you cut it in half, the halves are going to be the same size even though they use different pieces. So we can say they both have the same area. Calvin's rectangles are each half the area of the original paper. Matthew's are also half the original paper. So let's just say they are both half of the original paper. Which means they are equal. Number 7, Ben requested that the rectangular stage be split into 2 equal sections for the upcoming school play. The only instruction he gave was that he needed the area of each section to be half of the original size. If Ben wants the stage split to be into 2 right angles, did he provide enough information? Why or why not? Okay, so if he wants them into 2 right triangles, so let's say there's the stage. He wants it split into 2 equal sections. The only instruction he said was the area needed to be half the original size. If he wants the area split into 2 right triangles, so what he wants is this. He wants 2 right triangles. But all he said was that it needs to be half the original size. So if I were to do it, I would have just gone, oh, there you go. Or you could have said, oh, there you go. So someone might have just split it horizontally or vertically and would have done it like that. So I would say no, he did not provide enough information. Info. And the reason these don't work is because they don't give you 2 right triangles. So what he was looking for was this right here, 2 right triangles. And here we get 2 rectangles, and here we get another 2 rectangles. So that's why that doesn't work. He did not provide enough info because someone could have cut it. Could have divided it vertically or horizontally. How do you spell horizontally? H-O-R-Z. Horizontally. I'll rewrite that for you guys. Sorry. I'll work on my spelling. Okay, it is H-O-R-I-Z, I believe, horizon, O-N-T-A-L-L-Y. I think that's right. Horizontally, which would not make two right triangles. Okay. And I think the last one. Yeah, the last one, number 8. If the area of the right triangle is 6 22/100 square inches and its base is 3 11 inches, write an equation that relates the area to the height, h, and base. Solve the equation to determine the height. So the area of a right triangle, I'll just draw it out. It says, it gives us the area and its base is 3 11 inches, 11 hundredths inches. We don't know the height. So the area, which we know, so I don't need to write A. So 6 22/100 is equal to 3 11/100 times the height divided by 2. So then it wants us to solve. And what we can do is I'm actually going to do it this way. 1/2 times 3 11/100 times the height. So let's do 1/2 times 3 11/100. I'm just going to make it times 0.5. So 5/10, or 5 times 1 is 5, 5 times 1 is 5, 3 times 5 is 15. There's one digit behind the decimal point, so I'm going to move it over once. Oh, sorry, there's 3. Three, 1, 2, 3. So let's move it over 1, 2, 3 spots. So now we have 6 22/100 is equal to 1 555 thousandths times h. So the way that we can get rid of that is dividing by 1 555 thousandths. So let's do 6 22/100 divided by 1 555 thousandths. So in order to do that, I'm going to move this over 1, 2, 3 spots, which means I move this over 1, 2, 3 spots. Move it up. I'll put a 0 as my placeholder. So how many times can 1,555 go into 6,220? Honestly, I have no idea. So let's try 3. So 5 times 3 is 15. That'll give us 16. So we have 3. So there's 4,665. Okay, we get 4,665. Let's see if we can add another 1,555 and see if it'll get us close to 6,220, a little less, or over. Okay, be 10. Carry the 1. 1 plus 6 plus 5 is 12. Carry the 1. That'd also be 12. 1 plus 4 plus 1 is 6. So, we get exactly 6,220. So it goes in 4 times. Nice. So our answer is just 4. So that means the height would be 4. inches. 4 inches equals the height.